Hi everybody, in this video we are going to introduce the 6 trig functions from our second perspective, and that is the perspective of a right triangle. So here is a graph of our standard angle, and the point that defines our standard angle is going to be the point xy. And here you can see the right triangle. We've seen this before when we have looked at standard angles. And this triangle has 3 vertices, A, B, and C. Okay, each vertex represents an angle, so the angle A is this angle here. The vertex C is represented by this right triangle here, and of course this is B. The length Y is the side that happens to be opposite to A, and the length X happens to be the length that is adjacent to A. So if this is A, this is its adjacent side, and then this is its opposite side, and of course this would be the hypotenuse. Okay? Which of course is defined by the Pythagorean theorem. Now keep in mind the hypotenuse is always a distance, it will always be positive. On the other hand, x and y may be positive or negative. And with that in mind, we can define the 6 trig functions in terms of the opposite side, the adjacent side, and the hypotenuse. So instead of using x, y, and r, which are somewhat arbitrary, we can use something a little more geographically meaningful, namely opposite, hypotenuse, and adjacent with this right triangle. So now sine is going to be the opposite side divided by the hypotenuse. Cosine is going to be the adjacent side divided by the hypotenuse. And then tangent is going to be the opposite side divided by the adjacent side. And of course the reciprocal functions will be described in a familiar manner. So with that in mind, we can actually find the 6 trig values for angles A and angles B with this particular right triangle. Okay, so let's go ahead and get started. Now, the sine of A, this is A right here, is going to be equal to the side opposite of A, which is 36, divided by its hypotenuse, which is 85. Now let's go ahead and look at the cosine of B. Now remember, cosine is adjacent over hypotenuse, and the adjacent side is 36, and of course its hypotenuse is 85, which is kind of interesting. It turns out that sine of A and cosine of B have the exact same values, or more importantly, the sine of A and the cosine of its complement have the exact same value, and we're going to see this a lot. Okay, what about cosine of A? Well, the adjacent side to A is 77, so that will be 77 divided by 85. What about the sine of B? Well, once again, the side opposite of B is 77, and of course the hypotenuse is 85. And you can probably see how this is going to go. Okay, tangent of A, well, that's going to be the side opposite of A, which is 36, divided by the side that's adjacent to A, which is 77. And then the cotangent of B is going to be the adjacent side, the side adjacent to B, which is 36, divided by the side opposite to B, which happens to be 77. And of course, then we can use the exact same type of thinking to figure out everything else. Of course, cotangent is going to be reciprocal of this, so that's going to be 77 over 36. Of course, tangent of B is going to be the reciprocal of cotangent, 77 divided by 36. Okay, secant is the reciprocal of cosine, so 85 divided by 77. And cosecant is the reciprocal of sine, once again, 85 over 77. And then finally, we have cosecant of A, which is 85 divided by 36. And then secant of B is also 85 divided by 36. Well, not 7, 6. There we go. So you kind of notice that there is a relationship here. There is a relationship between the sine of one angle and the cosine of its complement. Keep in mind, notice that A plus B equals 90. So they are complementary angles. And the nature of this relationship is this thing called a cofunction, or more importantly, cofunction pairs, which we will discuss in our next video. Until then, if you have any questions, please feel free to contact me. This is Bob Boyle, signing off.